Hi, Miss Patterson here. Today we're going to go over enzymes, part of our biology unit. So first let's talk about what makes up an enzyme. An enzyme is made up of a bunch of amino acids in a chain that turn into a protein. So here I have amino acids. These amino acids are going to be a very specific type of code. Remember, DNA codes for proteins. So DNA is going to code for very specific amino acids. The amino acids are then going to chain. They're going to turn into a peptide. Then remember when we talk about these amino acids, these little peptides, there's little side chains. These little R groups are going to have very specific properties. And those are going to react. And then when they react, they're going to attract specific stuff to it, repel certain amino acids away, and they're going to fold very specifically. This specific fold, specific shape will have a specific function, and then this can be an enzyme. So there's over 2,000 known enzymes that we know of as of right now. And again, enzymes are made of proteins, so there's amino acids and chains. And if you want a review on proteins, I have a video. My AP Biology has one on proteins that will be very helpful. So an enzyme, here I have an enzyme. You can see all of these amino acids, all of these circles. They're all folded very specifically. And when they fold specifically, I can bring in something called a substrate. And the substrate's a molecule that can go into the enzyme. And what this enzyme is going to do, it's going to take that substrate and it's going to pull it and it's going to stretch it. And it's going to open up some of these bonds. And in the bonds, water can go in, something can go in, and it's going to help break that substrate. I can break substrates. I can put substrates together. So I can have one come in, and the enzyme's going to allow it to have an opening for a second. Water will be taken out. Okay, dehydration synthesis is going to bond it, put it together. So we call this, when I have the substrate and the enzyme substrate complex. This is all of those pieces together. The big takeaway from proteins, if I change the shape, I change the function. If I change the shape of the protein that makes the enzyme, I'm going to change the function of this specific enzyme. This one enzyme could be something that breaks down, it could be amylase, and it could break down amylose. And so this amylase is going to come in and it's going to break down amylose. But it's only going to break down this. It's not going to break down anything else besides that. If I change this shape, I can't break that down anymore. Enzymes are going to speed up reactions. They're not going to cause the reaction to happen. They're going to speed up reactions that will already occur. It will just take a very, very long time for them to happen naturally. So what an enzyme does is it speeds up this reaction. Without enzymes, the reaction inside the cell would be so slow that the cell would die or would no longer be able to function. It could take 1,000 years for one enzyme or one molecule to break down or come together on its own. The enzymes are going to allow it to happen very, very quickly. So this is what happens. I have a molecule that needs to break down or come back together. And for me to do that, I need a little bit of energy. On its own, I'm not going to be able to get over this little hump. We call this activation energy. I need this much energy to be able to come up to the top and then come back down. So think of it like a slide. If I'm by myself and I'm trying to go down the slide, I have to scoot up to the end. I have to get there. I have to take my hands. I have to push on the bottom of the slide, and then I can go down that slide. If I have an enzyme, this would be like having a friend with you. The friend's going to come up. The friend's going to give you that extra push. You still got to put a little bit of energy into it, but you're not putting half as much as you used to. So this enzyme is lowering this activation rate so they don't have as big of a hump to come over, and then you're able to go down that slide. So think of the enzyme as a friend that's kind of helping you out. Enzymes are very specific. There's what's called a lock and key complex. If I was at school and I have a key and the key opens up my door to my classroom. I can't go to any other classrooms and open up those doors. That's how enzymes are. The enzyme is going to be the lock. This is the lock of my door. The substrate is what I put in that causes a reaction to happen. So the key goes in my lock to my classroom and I can activate it. If I go across the hall to the art room or I go to another classroom, an English classroom, I can't open up those doors. My substrate does not fit that lock. So substrates have to fit the enzyme that it's made for. There's a very specific active site, and the active site is a very specific shape to fit this substrate. So we call this a physical fit. This will go in and it will fit this substrate exact. So if I have this substrate and I try to fit it into this enzyme, it's not going to fit right. I have a different shape. So I have to find the enzyme that will fit this one. So another enzyme comes in and then I'm able to make that fit. So the physical fit is for this. This will fit this enzyme, but this substrate cannot fit this enzyme, and vice versa. This substrate cannot fit this. So this will not activate or change anything if I have the wrong key for the wrong lock. Enzymes can be used over and over again. Once you use it, it's not destroyed, it's not broken down. So here I have substrate. A substrate is what's going into the enzyme. The substrate goes in, and then this enzyme again is going to pull tight, and then there's going to be water that's going to come out of this or come into this bond right here, and it's going to break it apart. So it's going to break it apart, it's going to go to another substrate, it's going to go in, it's going to break it apart, go on, so forth. But what you notice is I can only break one at a time. So this enzyme can only break one at a time. I can't break all three at once. This is going to break this one, this is going to break this one. Now I can also break them and put them back together, so you can have enzymes where this triangle and the circle will come in, and then I can have a reaction that puts them together. So I can break them apart and I can put them together with certain enzymes. I have what's called catabolic. Catabolic means to break apart. So here I have my substrate. I have my active site. This is going to be the part where the substrate fits. If the fit does not fit the substrate can't go in. Once it goes in, the enzyme's going to kind of hug it, squeeze it. It's going to start pulling it. It's going to allow a bond to open up here to either be broke or put together. This one's going to break it apart. And then when you're done with your enzyme, these are always called products. So the products is what comes out of it. Substrate goes in, products come out. But again, I can do it the other way. So anabolic, I have two separate pieces come in. Again, these are my active sites. Bond is going to form, bond is going to stay, and then these pieces are going to leave. And so now I have a new product here. The best way I tell people is the catabolic and anabolic. Catabolic's going to break it apart. And I say because cats can be jerks and cats can knock stuff off and cats can break things. So if you think of it, catabolic is the bonds or the substrate has broken apart and cats like to break stuff. So I kind of say that one, and that kind of helps people remember what's going on. Okay, that's our cover over enzymes. If you guys have any questions, let me know. Talk to you later. Bye.